Hello students, welcome back to a new program for Mathematics Grade 8. In today's video, we're going to talk about real numbers. Well, this is the second part of this chapter. Remember that in the first part, we talk about natural numbers, whole numbers, integers, and rational numbers. In this program, we are going to talk about terminating and non-terminating decimals, recurring or repeating decimals, and real numbers. So first, let's start with terminating decimals. Terminating decimals are decimal numbers having a finite number of digits after the decimal point. Examples of terminating decimals are 0.3. So you can see there's only one number, there's only one digit after the decimal point. 0.75, there are two numbers after the decimal point. Here we have three numbers after the decimal point. Here we have four numbers. So if we can count the number of digits after the decimal point, we call these numbers as terminating decimal numbers. Non-terminating decimal numbers. Okay, we have seen that terminating decimal numbers are those numbers where we can count the number of digits after decimal point. Non-terminating decimal means we cannot count the number of digits after decimal point. First, let's express 2/17 as a decimal number. Remember, this is something that you learn in grade 7. But since the denominator cannot be expressed as powers of 10, we must proceed with a long division so as to write 2/17 as a decimal number. Let's do it together. So we're going to divide 2 by 17. 2 cannot be divided by 17, so we add a 0. We're going to consider 2.0 as 20. If we divide it by 17, we're going to have 1. And then we subtract 17 from 20, we have 3. We add 0. Again, we divide 30 by 17. We're going to have only 1. The subtraction will give us 13. We proceed with adding zeros and proceed with the divisions. You will see that the more we divide, the more decimal numbers we'll obtain. And this division will continue indefinitely. That is, it will never end. Hence, this decimal number is called a non-terminating decimal. It has an infinite number of digits after the decimal point. Now let's talk about recurring or repeating decimals. We're going to take an example, same as the previous one. We're going to express 1/3 as a decimal number. Again, since the denominator cannot be expressed as powers of 10, we are going to proceed with a long division. So let's divide 1 by 3. 1 is less than 3, so we're going to start with 0 decimal. We're going to add a 0 here. We divide by 3. Of course, we obtain 3. The remainder is 1. We add a 0. Again, we divide by 3. We're going to have 3 in the quotient. Remainder 1. We continue to add 0 and proceed with the division. You will see that, again, this is a non-terminating decimal, but you're going to notice that the number 3 repeats itself. We have 0.3333, and so on. So we call such type of decimal numbers recurring or repeating decimal number. This recurring or repeating decimal number may be expressed in dot notation. That is, 4/9, if you perform the long division, you're going to have 0.4444 and so on. But you will ask yourself, how many 4s should we write? Instead of writing all these 4s, you can write simply 0.4, but with a dot above the number 4. A dot is placed over the recurring digit. That is, the digit that will repeat itself, we just put a dot above it. This is another example, 8 over 11. But here, we are going to have 0.72, 72, 72, and so on. That is, both the numbers 7 and 2 are going to repeat themselves in a pattern. So you're going to put a dot on both number 7 and 2. Now let's consider 5 over 12. 5 over 12 equal to 0.416666. It is the number 6 that is recurring. So you put your dot above the number 6 only. Number 4 and 1 appears only once. It is the number 6 that is recurring. So you write your dot only above the number 6. Now look at this example, 17 over 111. If you perform a long division, you're going to have this decimal number. Here, you will see that number 1, 5, and 3 repeats themselves in a pattern. So, writing it in dot notation, no need to write the dot above the 3 numbers that are repeating themselves. You will notice that number 5 is always between 1 and 3. So you write the dot only on 1 and 3. Now look at this one. Can you see a pattern in the decimal number? What are the numbers that are repeating themselves? Have a look at it. You will notice that these are the recurring numbers. We have 0.428571, again 4, 2, 8, 5, 7, and 1. So as dot notation, you're going to write 0.428571. You're going to write the dot above the 4 and 1 because you will always obtain 2, 8, 5, and 7 between these two numbers, that is 1 and 4. Here are some examples on how to write recurring decimals in dot notation. So students, now we're going to express the following rational numbers in decimal form. We're going to see whether they are terminating or non-terminating decimal numbers. Let's start with 2 over 5. Can you guess how to write it as a decimal number? Yes, you're going to write the denominator as 10 by multiplying both the denominator and the numerator by 2. So we obtain 4 over 10, which is equal to 0.4. We have only 1 0 in the denominator, so we're going to have one decimal number. Here, 2 and 1/4. The 2 is a whole number. We're going to write the 1/4 as a decimal number. 25 over 100. So it is same as 2 as a whole number. Then the fraction becomes 25 over 100, which is of course 2 decimal to 5. Negative 5 over 8. How are you going to write it as a decimal number? Okay, guess. Yes, we are going to write the denominator as 1000. So 8 times 125, so you're going to multiply the numerator also by 125. We have obtained here 625 over 1000. Here it is as a decimal number. You're going to see that we have 3 digits after the decimal point because we have 3 zeros in the denominator. How do we call such decimal numbers? Yes, terminating decimal numbers, because we are able to count the number of units after the decimal point. What about these numbers? They are recurring decimals. If we want to write them as dot notation, yes, there's only one dot because there is only number 6, which is recurring. This one, you're going to put 2 dots because both number 4 and 5 are recurring. What about this one? Should we write a dot above the 0? Of course not. It is the numbers that are recurring that should be written with a dot above them. Since we have number 2 always between 3 and 4, no need to write a dot above the 2. Example 3. Now write this dot notation in ordinary form. We have a dot above the 2 and 7, so we're going to repeat number 2 and 7. Now let's talk about irrational numbers. Remember, in the first part we talked about rational numbers. Now we're going to talk about irrational numbers. Irrational numbers are numbers which cannot be expressed in the form P over Q. Okay, so we're going to have non-repeating and non-terminating decimals also. So let's look at some examples of irrational numbers. Square root of 5. Square root of 5 equal to 2.2360, a non-terminating decimal. But square root of 5 cannot be written as P over Q. Second example, pi. Pi equal to 3.1415 and so on. Pi is an irrational number. 1 over square root 2. Again, we cannot write it as P over Q. Remember that when we are talking about P over Q, both should be integers, where square root 2 is not an integer. Don't think that 1 over square root of 2 is rational. It is irrational, because both the numerator and the denominator should be integers. The set of irrational numbers is an infinite set because we have so many irrational numbers. Which of the following are irrational? Think about them. Let's start with 0.5. 0.75 is rational because 0.75 equal to 75 over 100. It is rational. Square root of 3 cannot be expressed as a fraction of integers, that is P over Q. So it is an irrational number. Square root of 36 is equal to 6. Remember that we said that whole numbers are rational because they can be written as 6 over 1. This one, square root of 1 over 9, it is rational because square root of 1 is 1 and square root of 9 is 3. That is, square root of 1 over 9 can be written as 1 over 3. So it is rational. Among these 4, we have only one irrational number. Real numbers. The set of rational numbers and the set of irrational numbers together form the set of real numbers. So the set of real numbers is denoted by the letter R. Remember that when we talk about real numbers, we must always consider both rational and irrational numbers. That is, we're going to take the set of all numbers, whether it is natural, integers, fractions, decimals, terminating decimals, non-terminating decimals. All these numbers are called real numbers. So the set of real numbers is, of course, infinite. Now let's do some example with real numbers in general. For each of the following, fill in the boxes with one of the symbols. Less than, greater than or equal to. You will see in these numbers we have different types of numbers. You have recurring decimal numbers, you have fractions, you have negative integers. We're going to compare them. Let's start with the first one. -5 and 0. 0 is greater than any negative number. So -5 is less than 0. Look at this one, 0.63 and 0.63 with a dot above 6 and 3. What does the dot represent? Yes, recurring decimal. So which one is larger? Of course, 0.63 will be smaller than 0.63 with a dot above them. So 0.63 with dot above them are greater than 0.63 without the dot. So we're writing the sign here. Since 0.63 is on the left-hand side, we're going to write the symbol less than. For decimal 5 and 4.5. Of course, they are equal. This one. Yes, a negative number is always less than a positive number. Or the other way around, a positive number is always greater than a negative number. Now I'm going to give you some exercises for practice. First one, express the following rational numbers in decimal form. In exercise 2, you're going to express the recurring decimals using dot notation. Exercise 3, which of the following are irrational? You are also going to give an explanation why they are called irrational. Then you express 0.3 with a dot above the 3 in ordinary notation. In exercise 5, you are going to fill in the boxes using the symbol less than, greater than, or equal to. Students, it is advisable to log on the following website for reference. So students, in this video, you learned about terminating, non-terminating decimals, recurring or repeating decimals, and real numbers. This program ends here, but remember that this is the second part of the chapter Real Numbers. See you soon for the third and final part. Till then, goodbye.